Hello again. As you know, I'm Eli the Computer Guy over here for Everyman IT. Today's class is Introduction to Telephone Systems. So today we're going to be talking about business class and enterprise class telephone systems and the components that make them work. So this isn't simply the phone you have at your home and a little voicemail system. This is where you have something called a PBX and a voicemail system, which are basically like servers for telephones. We're going to talk about the telephones and how they work. We're going to talk about the central office, we're going to talk about trunk lines, etc. So today we're going to talk about all of the components that make a telephone system in a business or enterprise work. Telephone systems are relatively easy systems to administer. As a technologist, when you go out into the world, you are going to be presented problems with telephone systems. And I'm going to tell you, telephone systems are not that complicated, but most of us don't have any formal training in telephone systems. Therefore, we don't have the foggiest idea what to do when somebody comes to us with a telephone system problem. So, if they need an auto attendant fixed, we don't know how to fix that. If they have a problem with the trunk line, most people don't really understand what trunk lines are. So this is going to be an introduction class to telephone systems, and then past this class, we're going to go more in depth into what telephone systems do. Again, telephone systems are very simple. You just have to understand a few simple concepts that seem a little backwards, but once you understand that they are backwards, and that's just how it is, then everything gets pretty simple. So this class is Introduction to Telephone Systems. Give me a second to put a few things together, and then we'll dive in. Now, before we get into this class, I just have to say a word on voice over IP. So you're thinking telephone systems, and nowadays telephone systems mean voice over IP. You think. That's not really the case. What we're talking about today are traditional telephone systems. So these are telephone systems that have normal voicemail boxes. They are controlled by something called a PBX, and they have normal analog or digital telephone stations. This is not voice over IP. Understand, telephone systems are telephone systems. Voice over IP are data systems that transmit real-time audio communications in full duplex. So basically, a telephone system is a telephone system. This is a specific type of technology. Voice over IP is a different type of technology that just happens to transmit voice in real time. So you can use voice over IP to do the same thing you would do as you would on a phone call, but it's not really a phone call. It's voice over IP. So today's class, we're talking about telephone systems. We will have another class on voice over IP and unified communications, but that is not what we're talking about today, so don't get confused. This is telephone systems. We are talking about PBXs and telephones. Now, the first thing that we have to talk about when we were talking about telephone systems is we have to talk about what goes on outside of your building. So we will get into the PBX that sits inside your building, the voicemail that sits inside your building, the telephones that sit inside the building. But the first thing to understand with conventional telephones is what goes on outside the building. How does that telephone call get to you or get to your building in the first place? The first concept you have to understand is the PSTN. PSTN. This is called the Public Switched Telephone Network. So just like you have routers for the internet, the PSTN is basically like the internet for telephones. So this is how telephone calls get routed. So basically what happens on the Public Switched Telephone Network, PSTN, is you have things called central offices. So every area has a central office or a few central offices. So I'm not sure how many telephone lines a single central office does, but it's quite a few. So let's say Baltimore may have 5 central offices. A single county might have a central office. What this central office is every single house that has a telephone line in it. That telephone line that is sitting in their house, that little jack you have in the wall, that actually runs all the way back to the central office. So the wire that's in your wall goes out to what's called the demarc point in the back of your house. It goes into that demarc point, and then basically the same wire runs up to the telephone pole. And then on the telephone pole, that wire runs all the way back to the central office. So basically, you have a connection, a solid connection all the way from your house or your building all the way back to the central office. So that's how that works. And then what happens is the PSTN is then the network of these central offices. So let's say you're sitting here in, I don't know, Las Vegas, and you're trying to make a call to Boston. Using something called the North American Dialing Plan. The North American Dialing Plan is basically like a routing protocol if you're thinking about routers. North American Dialing Plan, NADP. You can Google it. We'll put a little resource at the bottom. But basically, this is the routing protocol for the telephone system. So when you're sitting at your building and you make a call to Boston, it looks at that telephone number, and depending on the area code and other things that are in that telephone number, it can then route that call to Boston. Or if you're trying to call Atlanta, it then will route through these central offices or through something called trunk lines over to Atlanta. So that's what central offices are. So the PSTN is a public switch telephone network. Think of this as the internet for telephone systems, basically. Then everybody connects to the telephone system through a central office. So you always have a central office. If you have a telephone with a dial tone, that connects back to the local central office, and you actually really do. The wire that goes from your telephone, if you trace it, it actually really does trace a mile or 2 or 3 miles away all the way back to the central office. Now the final thing to understand when you're talking about the PSTN, the Public Switch Telephone Network, and you're talking about central offices, is, of course, whenever you're dealing with technology, you're always dealing with authority. Who has control over what? So if you have the central office that's here, and you have your house that's right here, right? When you make telephone calls, the central office or your telephone company is responsible for everything that happens on the PSTN, the Public Switch Telephone Network. They have no responsibility for what goes on inside your building. So this whole cloud of the PSTN, they're responsible for. Your building, they're not responsible for. So, like I say, you have a wire that runs all the way to your building, and it's it goes over telephone poles and whatnot. Now the big point is on your building or on your house, you are going to have a little box that the wire that runs all the way from your central office is going to stop at. And this is called the demarc point. DEMARC. This is the demarc point. So your telephone company is responsible for the telephone signal all the way up to this box on the side of your house or on your building. So this is the demarc. If anything happens on this side, so anything, you don't have a dial tone because the wire got cut, etc., that is their problem and they will fix it. If anything happens on the building side, it is your problem and you were forced to fix it. So as far as the PSTN is concerned, the Public Switch Telephone Network, anything on this side of the demarc is their problem. Anything on this side of the demarc is your problem. It's just something that you should understand. So this is basically, it's a central office. Like I say, all telephone lines go back to a single local central office. That central office connects to other central offices and main trunk lines. And when you make a call, like I say, all the way out to Las Vegas or to Boston or to Seattle or whatever, the call gets routed using something called the North American Dialing Plan over the PSTN, the Public Switch Telephone Network. These are just basic overall concepts, but they are things that you should understand. So now that you understand a little bit about central offices and a little bit about the Public Switch Telephone Network, the next thing we have to talk about are trunk lines. So trunk lines are the lines, the telephone lines that allow you to communicate with the outside world. So if you have the central office here and you have your building here, The number of trunk lines you have determines how many phone calls can be going on with the outside world at any one time. So if you have one trunk line, that means either somebody can be calling in or somebody can be calling out. If you have two trunk lines, that means two people can be calling in, two people can be calling out, or one person can be calling out and one person can be calling in. So basically, however many trunk lines you have determines how many calls can be going on with the outside world from your building. So normally, if you have, like, say, a 30 or 40 person office, you will normally have 4 trunk lines to be able to communicate with the outside world, because most people figure, even with 40 people, there aren't going to be that many simultaneous calls going on. So even with 40 people, you can buy 4 phone lines and that'll be okay. Now the phone lines, so you'll have these 4 phone lines coming from the central office to your building. These will then run into something called the PBX. The PBX is the equivalent of a telephone server. So the PBX is what actually routes all telephone calls. So we're going to talk about the PBX in a minute. Just understand right now, it exists. So you have these 4 phone lines to the central office. Each phone line allows you to either make an incoming or an outgoing call. Now, one of the important things to understand with these trunk lines is every single line has its own phone number. So let's say line number 1, line number 2, 3, 4. So let's talk about like how Eli the computer guy was. Line number 1, our main phone number was 410-685-2808. The second number was 410-685-2885. The third was 410-685-2880. And the fourth was 410-685-2889. So every single one of these trunk lines coming in had its own phone number. Now you may be thinking, well, that doesn't make any sense, because when I called Eli the computer guy, when I call a normal business, all I do is I call that one main number and I always get through. Well, the reason that happens is when you have incoming calls, you have calls from the central office that come to your building. There is something being used called a hunt group. So what a hunt group is when you call 410-685-2808, I had it set up with the central office. So this is with Verizon. This is not inside the building. This is over here with the central office. I had a hunt group that was created that said, if 410-685-2808 is busy, forward the call automatically to 410-685-2885. If that is busy, forward the call automatically to 410-685-2880. And if that is busy, forward the call automatically to 410-685-2889. So basically, if any one of these phone numbers was busy, the call was automatically forwarded to the next number in the list. This is something called, let's put right here. This is something called a hunt group. And again, this is set up at the central office. This is set up with your telephone company, Verizon, Qwest, Bell Atlantic, AT&T. Whoever you have as your telephone company is the one that sets this up. So basically, you have these trunk lines coming in. So you can only have as many simultaneous conversations going on as you have trunk lines. So like I say, if you have 40 people, I would suggest you have 4 trunk lines. If you have 10 people, maybe you can have 3 trunk lines. But basically, every incoming call and every outgoing call will take up one of your trunk lines. Once you run out of trunk lines, nobody can call in and nobody can call out. Now, how this works from the outside world is that you set up something called a hunt group. So when somebody calls your main number, 410-685-2808, if somebody is already called and so this is busy, you will automatically be forwarded to 410-685-2885. If that is busy, you will automatically be forwarded to 410-685-2880, and etc. This is how this works. Not only that, but right now we're talking about normal telephone lines, so we're actually talking about telephone cables that run off the telephone pole and all the way down and into your PBX through some wiring. This is the same thing that happens even if you're using what's called a voice over IP trunk or you're using a T1 trunk. So no matter how you're doing it, every single telephone line that comes into your building or comes into your PBX, which is a telephone server, every single line has to have its own phone number. And then what you do, like I say, is you set up the hunt group to make sure that if one line is busy, it automatically gets forwarded to the next. Now the question you may have is, well, what happens when you're trying to call out? So you understand, so people trying to call in, get the hunt group, but people calling out. Well, what you can do is you can create groups, calling out groups within the PBX based on certain rules. So basically, what you can say is you can actually have this be the opposite. So you can say with calls going out, and you program this into the PBX, I want you to use the number 4 line first. So I want you to use 410-685-2889. If that is being used, then I want you to use 410-685-2880. If that is being used, I want you to use 410-685-2885. So basically, now within the PBX, you can program how you want people to be able to call out. Now let's say you don't always want it, or you want to make sure that all of your lines aren't always busy. Although you have 4 lines coming into your building, within your PBX, you could program the telephone system to only allow the last 2 numbers to be used for outgoing calls. So you could only have 2 outgoing calls. That's something that you can do. Beyond that, you can also program within the PBX like certain features. So let's say you have a line that has long distance on it. You can actually program in the PBX to say that only certain stations or telephones are allowed to call out and to use that particular line to make long distance calls. That's going to get into something that is much more complicated. But basically, to bring this back, so to make sure you guys understand what's going on, because we're going to have a lot of classes in this. The next class we're going to have is going to be about call routing. So in this class, we'll try to keep it a little more simple. The big thing is these trunk lines, like I say, every single trunk line is one incoming or one outgoing call, one call. So if you want 4 calls to happen at one time, you have to have 4 trunk lines. From the central office's perspective, if you want 4 lines and people to be able to call, so you have a main phone number and then you have these 3 other trunk lines, you set up something called a hunt group. So if 410-685-2808 is busy, it goes down to your second. If that's busy, it goes down to your third. If that's busy, it goes down to your fourth. That's set up again on the central office. That's called a hunt group. So you just call up Verizon and you say, I have these 4 phone numbers. I want to set up a hunt group. This is how I want it to work. Then, when you're talking about outgoing calls, so you're talking about you're sitting inside your building and you're going to call into the outside world, you can set up rules and you can set up out-calling groups within the PBX. The PBX is basically the telephone server. And you can put in all kinds of insane rules in the PBX, and like I say, we'll talk about that in the call routing class. But understand, so calling out using the trunk lines gets programmed into the PBX. Coming in gets programmed at the central office. You call Verizon or Qwest or AT&T or Bell Atlantic. Going out, you program inside your own PBX. So this is essentially how trunk lines work. Like I say, right now we're just talking about normal wires coming in from the telephone line, but this is the exact same case whether you're using T1 or voice over IP trunks. This is the basic concept of how it works. So we've talked about the public switched telephone network, the PSTN. We've talked about the central offices. Now we've talked about the trunk lines that come all the way to your building. Now once these trunk lines get to your building, they're going to hit something called the PBX. The PBX is, for all intents and purposes, the telephone server. This is what routes the telephone calls that you're making on the system. So if you're trying to call your boss in the room over and you just dial an extension 345, the PBX is what routes the call from you here over to your boss. So the call goes into the PBX and then it goes over to the boss, the extension. If you're trying to to contact somebody out on the public switch telephone network, and you make a call, it goes into the PBX, and then the PBX routes that call out to the public switch telephone network. So the PBX is basically the server that routes all the calls. Now PBXs are really cool. Like I say, we're going to have another class on call routing because you can do insane, amazing things with call routing. There are a lot of things that ways you can route calls. You can put permissions on lines. You can create call groups, hunt groups, just out calling, just a lot of cool stuff. But that'll be another class. The main thing that you have to understand is that the PBX is like the server or maybe the router for your telephone system. If you call another extension in the building, it is what routes the call to that extension. If you call out to the outside world, the PBX is what routes the call to the outside world. If a call comes in from the outside world to your building, the PBX is the one to route it to you or to your boss or to a voicemail system or to wherever. Basically, the PBX is what routes all the calls. Now, PBXs are, like I say, we'll get into a class on them, are really not that hard to administer. If you understand a few concepts and you understand what you're supposed to be doing, PBXs aren't that hard to administer. Now, one of the hiccups the telephone companies threw into the telephone system is that for some reason they divided the PBX and the voicemail systems and made them separate. So your PBX and your voicemail system are not normally the same box. The voicemail system is actually an add-on to the PBX. So you'll buy a Via whatever they are, PBX for $600, and then you have to buy a voicemail system that connects to that PBX for another $500 or $600. And so all of the voicemail stuff is controlled by the voicemail system. Like I say, with a Via, this is called Audix, AUDIX, whatever telephone system company that you're dealing with, they'll probably call it something else. But the main thing is the PBX routes the calls. The voicemail is what deals with all the voice. So, all the voicemail stuff. Here's the weird problem, and something that you kind of just have to have in your head is, so the PBX routes all the calls and the voicemail deals with all the voice stuff. Now, one of the weird things is, as we'll talk about in the routing class, the call routing class when we have it, is when you create something called an auto attendant. So an auto attendant is where you call into a business, and then as soon as you call in, it goes, "Thank you for calling Eli the Computer Guy. If you need sales, press 1. If you need tech support, press 2. If you need to just go away, press 3. So that's what an auto attendant is. Auto attendant hell, as many of us know. So you call in and you get this message, and then it says, press 1 for sales, press 2 for this, press 3 for that. Here's one of the weird hinky things. That message that you're listening to resides on the voicemail system. The routing that happens when you press 1 or press 2 or press 3 happens in the PBX. So when you set up something called an auto attendant, that doesn't all reside on the PBX. Basically what happens is within the PBX, you say, I want extension 800 to be an auto attendant. And then you put in, if somebody presses 1, go to, extension 304. If somebody presses 2, go to extension 305. If somebody presses 3, go to extension 306. And if somebody presses 0, hang up, right? So that is what is programmed into the PBX. But the message that you are hearing is in the voicemail. So what will happen is you'll create extension 800. It'll be an auto attendant. It will have all these settings. And then it will also say, play voicemail box 800. So basically, you have to point this auto attendant that's sitting in the PBX to a voicemail box sitting in the voicemail system. Again, when we go into call routing, as we get more into all of this, this will make more sense once we're actually doing it. But the main thing to realize, which can be a real pain in the butt, is a lot of the the normal functions that you think about with the telephone system are actually split between what's called the PBX and between the voicemail system. These are two entirely separate systems. Even if they plug in together, etc., they're two different systems. Even in the voice over IP realm, they've kind of kept this hinky-ass setup. So even though in voice over IP everything really does reside in the same server, they've still kept this whole mess where the PBX, the call routing functionality, and the voicemail functionality are separate. Just understand, whenever you're dealing with routing in the PBX that requires a voice prompt, like I say, thank you for calling Eli the computer guy. If you want sales, press 1. If you want whatever, press 2. That message is always going to reside in the voicemail system. So whenever you're setting up something within the PBX that requires a voice prompt, you're going to have to point that rule to the voicemail system. Like I said, that may be a little hinky right now, but you'll understand it later. The main thing is whenever you're dealing with a telephone system, so all the trunk lines come into your building. Those trunk lines, however they get there, are going to connect to the telephone system. The telephone system is fundamentally two parts. The PBX is what routes all the calls. So if you call a local extension, it is what routes the calls. If you call out to the outside world, it is what routes the calls. If somebody calls in, it is what routes the calls. And you have the voicemail system. So if the PBX routes a call and you do not pick up, then the PBX routes the call to the voicemail system, and that's where you get the voicemail prompt. Thank you for calling Eli. I'm sorry I'm not here. Please leave a message after the beep, beep. That component sits in the voicemail system. So these are two different critters. Like I say, as we go along, this will all make a lot more sense. But this is the basic telephone system. So let's talk about stations. Now, what are stations, you may ask? Stations are what you may think of as telephones. But just like the computer world, where they come up with a whole bunch of new lingo to explain what you thought you always understood, telephones are no longer telephones. In the telephone world, telephones are stations. So there's a reason for this. And what you have to understand is, remember, a telephone system is a system that allows you to do audio communication. So it allows you to call people, but it allows you to do more than simply make normal telephone calls. So when you have a station, you may have your normal telephone, but you may also have an intercom system. So with a lot of these telephones systems, you can actually call an extension. So if you need somebody in the warehouse, you can call an extension. You can say, Bob, we need your help up front. And that will go out through the speakers in the warehouse. Bob, we need your help up front. So that speaker system, or an intercom system, is considered a station. You can also have, when you go to an apartment building and you have a little front door and you have one of those little call boxes, that is a station. So when you're dealing in the telephone world, telephones aren't really always telephones. Telephones are stations. So stations can be the telephone that you're used to. It can be some kind of intercom system. It can be that call box up front. All of these things will connect back to a PBX, and calls will be routed accordingly. So basically, with this call box here, you can route in the PBX and to say, if anybody presses this button on the call box, that is going to ring the secretary's desk. And so when somebody presses the call box, that will actually ring the secretary's desk. The secretary will pick up the telephone, say, hello, how can I help you? And you'll be able to talk in. Again, this intercom system will be an extension, let's say 805. So if you're sitting at a telephone and you plug in the extension 805, when you start talking, that is going to go out over the intercom system, in the warehouse or wherever. So with PBXs, with telephone systems, you're dealing with more than telephones. You're dealing with intercom systems, call boxes, etc. Now, how these telephones and these call boxes and all that communicate back with the PBX is something important to understand. So you have your PBX right here, and then you have your telephone. Now in a normal, like I say, we're not talking about voice over IP here. Get all that crap out of your head because we're not talking about that right now. In a normal telephone system, you have two ways to transmit communication. You either have analog, or you have digital. So you can have an analog telephone line or a digital telephone line. This is very, very, very important. So the standard telephone you have at your house is probably an analog telephone. If you just plug it straight into the wall jack in your house, that's an analog telephone. To understand, an analog telephone, for all intents and purposes, is a really complex version of the can and string telephones you used to play with as a kid. So, you take two soup cans, you drill a little hole in the back of the soup cans, and you run a string, and somebody talks into one end, and somebody puts the thing up at the other, and you can hear the conversation, right? An analog telephone system, like I say, is just an incredibly complicated version of that. So when you talk into the little microphone that's sitting, on your telephone or the call box or whatever, your actual voice, that sound wave, is maintained. It's put on something called carrier waves, etc., to make the phone call happen. But your actual voice is transmitted all the way to the person on the other side of the line. So whether the person is sitting in an office, 3 doors down, or whether the person is sitting in Japan, if that is an analog telephone call, your actual sound waves are getting transmitted all the way over to Japan. The problem is since your actual sound waves are getting transported all the way to Japan, if there's any static or if there is any interference on the line, that interference gets put onto that analog line. So basically, if you're talking over a long distance and there's a thunderstorm, that thunderstorm can create interference, and it makes static and the rest of that. So what they did is they came up with digital communication. So what digital communications telephone systems do is they turn your voice into ones and zeros. So if you look at something called an oscilloscope, instead of having sound waves, you have something that looks like this. This is basically, it turns your voice into ones and zeros. Now this is important when you get to your telephone system. So, analog takes your real voice. It's actually your voice all the way to Japan. Digital turns your voice into a digital signal and then transmits that and then puts it back together. So what happened in the old days, 20 years ago for PBXs, telephone manufacturing companies wanted to offer more and more features to the people buying telephone systems. Now the problem was, in order to have those features, they couldn't use the old analog telephone handsets because they were not capable of giving the features. So they started selling digital telephones for digital telephone systems. So this is where the telephone communicates with the PBX using ones and zeros. So it's a digital call. But as we'll go into in other classes, this gives a lot more functionality to this telephone. The problem is an analog phone cannot understand what a digital signal, and a digital phone cannot understand an analog signal. So if you have a digital PBX and you plug in an analog phone, nothing is going to happen. You will plug in the phone, you're not going to get dial tone, you're not going to get anything, because that analog phone does not understand how to talk to a digital telephone system. If you have a digital phone and you have an analog telephone system, again, the phone is not going to work because the digital phone does not understand the analog system. So this is important when you're buying new or newish PBXs. They will normally have both analog and digital ports, because like if you buy a fax machine, most fax machines are analog. So if you try to plug that fax machine into the digital port on the PBX, it's not going to work. So what happens on most of these PBXs, on the back of it or on the front of it, it looks almost like a switch. So you'll have however many ports you have telephone lines out to those stations, right? And then at one point, you'll most likely have a couple of analog ports. So you'll have digital ports, and these go to digital phones or digital fax machines or digital intercom systems. And then you have a few analog ports. This is what can go to your normal standard analog fax machine. If you have a modem, so I don't know if you're still using a computer modem, that's what you would have to plug into. This used to be a big problem back when I worked in the corporate world, 10 years ago, because everybody still used modems to get email and all that. So they would come to our corporate offices, they would plug into what they thought was a normal telephone line, and they couldn't get anything. They couldn't get dial tone, they couldn't dial out, etc. The reason is because they were plugging into a digital port, and so their little fax machine didn't do anything. So the main thing to remember, like I say, with stations is when you get into the telephone world, telephones are no longer telephones. Telephones are stations. So there are a lot of things that stations can do. Stations can be telephones. Stations can be intercom systems. Stations can be call boxes. All of those are stations. All of those connect back to the PBX at some point. Then, when you're dealing with the PBX, remember, most PBXs, they're either going to be digital or analog. Some of them have both digital and analog ports. The main thing that you have to understand is you have to plug your device into the right port. If you have a standard fax machine or a standard modem and you plug it into a digital port, it's not going to work. If you have a digital phone and you plug into an analog port, it's not going to work. So digital devices have to get plugged into digital ports. Analog devices have to get plugged into analog ports. If you remember all that, it's pretty simple. So as we talked about, the telephone system has both the PBX and the voicemail system. Although they may be connected together, although they may even be in one box, engineering-wise, they're still two separate things. So when you're talking about the PBX and you're talking about telephones, you're talking about the PBX and stations. When you're talking about voicemail, you're not talking about like people or users, you're talking about subscribers. So whenever you are talking about users of a voicemail system, you are talking about subscribers to that voicemail system. Now, like I say, the voicemail system can do a lot of different things. Obviously, you can do voicemail. It can have little bulletin board messages on the voicemail system. So, like I had one client who wanted to tell people what their tax ID number was. So you could call in to what was called an auto attendant, and it would say, "Thank you for calling XYZ. If you need to talk to somebody, press 1. If you need directions to our place, press 2. If you need our tax ID number, press 3. If you pressed 3, all it did, there was no voicemail box, there was nothing. All it did was just a voice message. It said, "Thank you, our tax ID number is 57896611." So all that voice stuff happens within the voicemail system. Now, a big thing to understand with subscribers is subscribers don't always have to be attached to stations. So stations are the telephone. Subscribers are the users of the voicemail system. Well, like with a lot of companies, you may call in, let's say, to like a sales department, and the salesperson actually doesn't have a desk at that company. All they did is they created a voicemail box for that salesperson. You call in and you will never get them on the phone. They don't have a telephone sitting on their desk because they don't have a desk. So whenever you call in to get that person, it automatically routes to their voicemail box. So that's a big thing to understand with voicemail systems is subscribers may have a station attached to them, may have a telephone associated with them, but they don't have to have a telephone associated with them. So like I say, is if you're dealing with a company that has a lot of like field people, you may just have 50 mailboxes, voicemail boxes, without telephones, because when people call in, you just route them directly to their voicemail. The other thing, like I say, that the voicemail does is for things like message services. So you can put on, you can say what the directions are to your facility. You can say what your hours are. You can say tax ID number, etc. And then The voicemail box is also where you put all the voice instructions for something called the auto attendant. So the auto attendant is what routes your calls. Like I say, when you call in to a business and it says, thank you for calling Eli the Computer Guy, for sales, press 1. That message is all residing in the voicemail system. So those are the important parts of the voicemail system. The final, again, hinky part with voicemail systems that you have to be careful about is you have to make sure you buy the right number of ports. Now, as I've said before, remember, the voicemail system and the PBX, the telephone server, are actually two different components. So when you buy the PBX, you may have 4 incoming trunk lines and let's say 9 station lines, right? So you think if you plug in the voicemail system that all the people that are going to be calling in can get into the voicemail. That's not necessarily so. When you buy the voicemail, you also buy a certain number of ports. Ports are the number of people that can be using the voicemail system at any one time. So if you have 50 subscribers and stations, and you only have 2 ports, that means only 2 people will be allowed to access the voicemail system at any one time, no matter how many trunk lines you have coming in. So you could have 10 trunk lines coming in, but when you hit the auto attendant, so if you have 1 person hitting the auto attendant, then 2 people hitting the auto attendant, the third person, they're gonna hit the PBX, but they're not actually going to get any messages. They're not going to be told anything. So because you only have 2 ports. So the big thing to understand with voicemail, the stupid thing, is remember, the number of ports you buy says how many people can be accessing the voicemail system at any one time. Again, some of these lower end systems, they initially sell it to you with only 2 ports, and you may have to spend $400 for another 2 ports. So you may not be thinking about it. You may be getting all these complaints because when people are calling in, they're not getting the auto attendant. It's not because there's any configuration problem. It's because you have not bought enough ports. So with the voicemail system, the number of ports you buy are the number of people that can be interacting with the voicemail system at any one time. Once you go over that number of ports, you don't get anything generally. So like I say, in the voicemail world, users of the voicemail system are called subscribers. Not all subscribers have to be attached to stations. You can have voicemail boxes without stations, without telephones. Again, the voicemail is what gives all the voice prompts. So like I say, whether it's auto attendant, whether it's message boards, etc. But it will only allow however many ports you have purchased to access it. So like I say, if you have 50 users and you have 10 trunk lines, but you only bought 2 ports for your voicemail system, only 2 people can be interacting with that voicemail system at any one time. It's hinky, it's stupid, but it's how it works. So that was the class on Introduction to Telephone Systems. Like I say, this is just supposed to be an overview. We're going to have more in-depth classes on how all this works. Again, telephone systems, compared to servers and compared to networks, they're a joke. They're very easy to administer, but the main thing is you have to understand what you're doing. You have to understand all of these concepts. Once you understand the concepts, it's very easy. If you don't understand the concepts, it's all just gobbledygook, probably like everything else is. We talked about the outside world. So we talked about how calls actually get to your building. So we talked about the North American Dialing Plan, which is basically like the routing protocol for the public switched telephone network, the PSTN, the public switched telephone network. Think about as an internet for telephone calls. So when you're in Las Vegas and you're calling somebody in Boston, you dial the number. The number you dial, based on that number, the North American Dialing Plan looks at it, and then through the public switch telephone network, it routes that call all the way to Boston. Now, once it gets to Boston, as I said, every single phone line you have, every cable that runs from your building goes back to a central office. So the central office is the first point that everybody connects to. So, like I say, at your house, your telephone line literally runs all the way back to the central office. Now, the main thing, as I said, is there's the demarc point on your building. This demarc point, like I say, with Verizon, it's a little gray box that's normally screwed to the outside of the building. And the telephone company is responsible for everything up to that gray box. box. On the other side of the gray box, on the other side inside your building, you are responsible for everything. So that's something just to keep in mind. We talked about, like I say, this class was on telephone systems. This class was not on voice over IP because voice over IP is not telephone. It is real-time audio communication using a data network, which simulates a telephone, which is a lot like a telephone, but it's not a telephone. Telephones are telephones. VoIP, or voice over IP, is audio communications over data networks. They are two different critters. We will have a class on voice over IP so you understand that better. We talked about the trunk lines. So the trunk lines, however many trunk lines you have, are how many concurrent communications you can have with the outside world. So every incoming call uses a trunk line. Every outgoing call uses a trunk line. So if you have 4 trunk lines and you have 4 incoming calls, you are not going to be able to make any outgoing calls. If all your salespeople are trying to make a lot of calls and they're calling out, you have 4 trunk lines, you have 4 of your salespeople calling out, then nobody can call in. So your trunk lines are the total number of communications you can be having with the outside world, either incoming or outgoing. Like I say, every single trunk line has its own phone number. Whether you actually have the telephone cable that runs into your building, or whether you're using a T1 line, or whether you're using what's called a voice over IP trunk, every single phone line or trunk line has its own phone number. So, with us, you have the main number, which was 410-685-2808. We then had 3 additional telephone numbers. With the central office, with Verizon, we called and we created something called a hunt group. So if the first phone number was busy, 410-685-2808, invisibly to the caller, the call was automatically forwarded to the second phone number on the list. If that was busy, it was automatically forwarded to the third number on the list. And if that was busy, it was automatically forwarded to the 4th number on the list. So this is how incoming calls happen. So whether you have 2 trunk lines or whether you have 100 trunk lines, all you do is you create this hunt group. So if this is busy, go to this. If this is busy, go to this. If this is busy, go to this, etc. It's very easy. Now, that's on the central office, the telephone person side. So incoming calls. Outgoing calls, all of that is controlled by your PBX. And like I say, we will talk more about programming PBXs and call routing later. But basically, when you're calling out, you can also create rules. You can create rules about what stations can use the long distance telephone number, that kind of stuff. All the outgoing routing is controlled by the PBX. We talked, that the PBX and the voicemail system, even if they now reside in the same box, engineering-wise, for whatever reason, they are logically divided. So the PBX is what routes the telephone calls. The voicemail system is what has all the audio prompts and audio boxes. So any audio stuff you hear, thank you for calling Eli the computer guy, please leave a message after the beep. Any of that kind of stuff is sitting within the voicemail system. Like I say, it gets a little hinky and a little weird, but that's how it works. We talked about stations. So when you look at a telephone is no longer a telephone. A telephone is a station. Now, stations can be any number of things. They can either be what you think of as a telephone. They can be an intercom system. They can be a call box system. They can be anything that an engineer comes up with. So basically, any communications device that connects back to the PBX is a station. Like I say, all you do with the stations is you create a little extension in the PBX, and then let's say you have an intercom system in the warehouse, you can just pick up the phone, you can dial whatever that extension is, and you can say, hey Bob, I need your help up front, and that will go out through the warehouse. Now we talked about that there are analog stations and digital stations. So when you have your PBX, it'll either be an analog PBX or a digital PBX or a mix of both. So a lot of times now you will have digital lines on the PBX and analog lines on the PBX. Analog phones or analog stations can only communicate through an analog port. Digital stations can only communicate through a digital port. So if you take your phone from home into the office and you plug it straight into that PBX, if that is a digital PBX, your phone from home will not work because your phone from home is an analog phone. This gets really important, like I say, when you're plugging in things like fax machines. So you buy this really fancy, expensive $3,000 fax machine and you can't figure out why you can't get the damn thing to fax. Well, the reason is probably because you plugged it into a digital line on that PBX. You just need to plug it into the analog line. We talked about the voicemail system, and again, in the voicemail system, you talk about users of the voicemail system as subscribers. So anybody who has a voicemail box is a subscriber. Voicemail boxes or subscribers may have stations, they may have telephones connected to them, or they may not. So like I say, the modern companies, all they have in their telephone system is voicemail boxes for, like I say, their salespeople. So whenever you call in, you will never get that salesperson to actually pick up the phone. You automatically always get routed into the voicemail box. It's just something to understand. And then finally, like I say, this is hinky, this is dumb, this just wants to make you punch the sales and legal people. But depending on what voicemail system you use, you may have to worry about buying ports. So what ports are basically licenses for concurrent connections to the voicemail system. So like I say, I used to buy Avaya voicemail systems, and they would come with a standard of 2 ports. That means only 2 people can be using the voicemail system at any one time. The reason this gets really dumb really quick is that it does not just mean that your employees are calling in to check what their voicemail is. That also means people calling in from the outside world, if all of those ports are being used, they will not hear that auto attendant. So I would suggest at the very minimum, you get the same number of ports as you get trunk lines. So if you have 4 trunk lines coming in, get at least 4 ports. I mean, that's be a nightmare. It can be really, really horrible. That's the basic class, the introduction to telephone systems. If you're going out and you're going to start trying to administer these telephone systems, like I say, hold on. We're going to have a few more classes before you even try to start touching them. One of the things you have to realize, again, that makes telephone systems such a pain in the butt is especially lower end telephone systems. So we're talking about telephone systems like, say, $10,000 or less. Many times the only way to administer these telephone systems is actually through the telephone itself. You know, whether you're creating auto attendants, whether you're creating really complex plans, you have to do it all through a telephone. So you know how like you call your cell phone voicemail and it says, you know, if you want to change your greeting, press 3, and so you press 3, and it says if you want to change your whatever greeting, press 1. If you want to change your busy greeting, press 2, and you go in. Well, imagine having to do that for something that's much more complex, multiple auto attendants, multiple stuff. Just understand that a lot of these telephone systems you actually have to program using the telephone. So you dial some code and it says, thank you for logging into the Avaya telephone system. It is illegal to use this for improper purposes. What would you like to do? And you go, okay, I'll press 9. Thank you for getting into this administrative console. If you would like to change this, press this. And then you have to administer that way. It can be royal, just complete pain in the butt. And so that's what I will caution you with. If you're thinking about administering some of these telephone systems, is because if you do something dumb and you wipe out a configuration, it's not like a little GUI, a little graphic interface where you can just put it back and it's okay. If you do something dumb like delete an auto attendant, I mean, it may be hours upon hours of work to try to recreate that auto attendant using just a telephone keypad to do it. Yeah, it really can be that bad. So that's one of the last things I'll say, just the warnings, you know, the final thoughts, warning, is like I say, a lot of the lower end telephone systems you have to administer actually through the telephone. You can't plug a computer into it, etc. And that can be just a royal pain in the ass. So as you know, I'm Eli the Computer Guy over here for Everyman IT. This is Introduction to Telephone Systems. We're going to have a lot more courses in this track. So if you're not fully up at this point, up to understanding everything, don't worry. There's going to be a lot more courses, and all of this will make a lot more sense. This is just the basic components of what telephone systems are made up of. Now that you understand this, we can go off to call routing, and we can go off to voice over IP, and we can go off to a lot of the cool stuff. So as always, it was really good teaching this class, and I look forward to seeing you in the next one.